the core confusion, let's name it. How does decentralized state keep a global state like Redux does? Short answer, it doesn't keep one global state object. It keeps a global dependency graph instead. So remember the node or the graph data structure that we discussed in data structures and algorithm. I recommend you going back on that. That's what the RiverPad use. Redux global state, one object. RiverPad global state equal many independent nodes. That difference matters a lot. Second, Redux mental model, precise, not hand-wavy. Redux has one global state tree, single JS object, two reducer transform it. So basically, when an action uh, put on that reducer create a new state. Then subscriber on that reducer re-render, and that all happening in in-memory object or data structure. Basically, it's just changing your UI to reflect that new backend. Key properties, single immutable object, time travel is easy, copy the tree, so it's still using the same tree or node data structure. Same with React, it also use, because it's using React as well, React use a tree data structure, and RiverPad also are compiled to JavaScript. So basically, they're all JavaScript if you're talking about web development. Everything depends on the same root. Think state equal open semi-curly bracket, next line auth colon, open semi-curly bracket, dot, closing semi-curly bracket, comma, next line profile colon, open semi-curly bracket, dot, closing semi-curly bracket, comma, next line post, colon, open semi-curly bracket, dot, closing semi-curly bracket, then closing semi-curly bracket. That's where Redux Dev Tools can rewind everything. RiverPad or provider mental model, the correct one. RiverPad does not keep a global state object. Instead, it keeps a global container, two providers, independent state nodes, then dependency graph. So if one of the dependents in the tree or the children change values, that's the only uh, time that the parent or the root tree will change as well. And there's only one root tree. A root tree could not further change it's like another root tree, because there can be one root tree, just like with other data structure that we discuss in data structures and algorithm. Each provider owns its own state. It knows who depends on it, then recompute lazily. What recompute lazily is that when you change the value, that's the only time it will recompute upwards, and then change the return value to or render the return value to the user. Otherwise, if the value doesn't change, it just return the same output or cache the same output. Example, final auth provider equal provider auth argument ref, open semi-curly bracket, closing semi-curly bracket, closing parenthesis, semicolon, next line, final profile provider equal future provider, open less than profile, closing closing greater than open parenthesis ref, closing parenthesis, open semi-curly bracket, closing semi-curly bracket, closing parenthesis, semicolon. There's no single object like Redux state. What's global then? The provider container. That's the global. The dependency graph, the lifecycle rules. Basically, you have one container and then you have dependent graphs. So you have like a different dependency on each node, and you also have different lifecycle rules. Now, all of those, like each node contains its dependency, and each has different life cycle rules, and each has a different root. Now, those are what makes it global, because when you change something, it will, what do you call this, level up or goes upward. I think there's trickle up. So the change will trickle up, and all of those dependent on that will change. It's not like a global state like Redux, where it instantiate a new state each time an action or dispatch, each time reducer instantiate a new state. So that's the global part. Your SQL example, map correctly, important. Your SQL profiles, open parenthesis, next line ID, UUID, primary key, comma, next line display underscore name, text, comma, next line photo underscore URL, text, closing parenthesis. This is not global state. It is durable authoritative state. Redux or River pad state is a thermal derived state. So the reason why this is SQL is durable authoritative state is because, remember, this is a code, and then the data being executed, where it is being executed is permanent. It's kind of like the facts. It is the facts, and it's the single source of truth. While the river pad in Redux, it's just an in-memory. It's like a denormalized state, not yet final until it is committed here. So correct layering, Postgres source of truth to Supabase API, to client cache, river pad, or Redux to UI. Error of omission, you are implicitly treating database rows like Redux global state. They are not the same category of state. So they have both have a state, right, at any given time, but they have a different category, because Redux is in the user space, while database from another app, and another, I mean, user space are have, like, virtual machine and converted to JavaScript objects, and then there's a browser runtime. But for database, it's still a user space, but it's in another, kind of like another dimension, because it's using storage engine under hood. How decentralized state still feels global? RiverPad feels global because, first, providers are globally addressable. Ref.watch, profile provider, anywhere in the app. So this ref.watch is what makes it global. So it's kind of like what makes the memoization in the data structure we discussed in data structures and algorithm, because it allows us to know if something has changed. Otherwise, it will just return the same output. Second, providers can depend on providers, like this: final profile provider equal future provider, argument rep, open semi-curly bracket, next line final user equal ref.watch, argument auth provider semicolon, next line return, fetch profile, argument user.id semicolon, closing semi-curly bracket, closing parenthesis semicolon. This creates a directed acyclic graph. So basically, it's just a tree. It's a node data structure under hood. Redux, so again, no data structure. It's still in memory, because again, that's data structure in algorithm, or in-memory data structure. It's not like a data structure that you would persist in a storage. Remember how the data flow from disk to memory to L1 cache, to L3, L2, L2, CPU, and then go back to memory again, and then to disk, etc. So Redux UI to global state, RiverPad UI to provider to provider to provider. So that graph is your global state. So you can think of this as edges, like we discussed in graph data structure. So Neo4j is part of a graph data structure, etc. For you to remember what are the examples of a graph database. Language boundaries, you asked this very clearly. So the language logic of my Flutter is RiverPad? No, Dart is the language. RiverPad is a Dart library. And all of these are compiled to JavaScript if it's a web application. RiverPad is written in Dart. Uses Flutter or Dart runtime features, isolates async streams. Your state logic language equal Dart. Your UI language equal Dart. Your backend language, Supabase Edge equal TypeScript. Your DB logic equal SQL or PLPG SQL. So the backend, the Supabase Edge is just a TypeScript. The Supabase that connect to PostgreSQL. 7. What exactly is the state in RiverPad? Very important precision. RiverPad state is a value produced by a function cached by the runtime. So this is how it's being returned as the same output because it is just there in memory. So the memory won't change or the rendering won't change until a new value has changed. And that new value will only be changed by a function, right? Because that's even in CPU, that's how it works. You need to have an instruction first before you can change the data or a value. Example, final counter provider equals state provider int ref 20 closing parenthesis semicolon. This is closer to memoize function output. So it's similar to the memoize data structure we discussed where you're caching something in the memory. So this entire or one line of code, final counter provider equals state provider less than int greater than open parenthesis ref closing parenthesis equal less than 0 closing parenthesis semicolon then to mutable object because Redux is equal object mutation via reducers. RiverPad equal value replacement via recomputation. So you change the value via recomputation. It's not like a diffing algorithm of React where you calculate the new virtual model. So let's change our mental model on that. Number 8, your Firestore on snapshot versus Flutter equivalent. Firestore JS on snapshot argument docref comma callback. Next line Supabase argument Flutter. Then Supabase next line dot from argument code profiles next line dot stream argument primary key colon argument code ID next line dot descend argument data open semi-curly bracket next line slash slash or comment update profile state closing semi-curly bracket closing parenthesis semicolon RiverPad native way final profiles provider equals stream provider argument rep open semi-curly bracket next line return Supabase dot next line dot from profiles next line dot stream argument primary key colon argument ID closing parenthesis semicolon next line closing semi-curly bracket closing parenthesis semicolon. So this is your on snapshot difference. Firestore pushes diffs, Supabase streams while changes. So the Firestore is what pushes the diffs, kind of like with the React Virtual DOM, where it pushes the recent change, while Supabase streams while changes. So it used the streaming we used with our previous chapter in database, just like the streaming in Twitter. That TypeScript Suva base used the wall that column storage and the storage engine use row oriented and column oriented. While River Pad reacts, it does not poll. It just reacts inside the memory. It doesn't like have like persistent connection. And also Supabase connect to browser via WebSocket. So that's how it polls it. That's how it streams while changes. And Firestore pushes dips. Still use HTTP. Still use WebSocket. So it polls or pushes the dips using WebSocket. Very important correction to your model. The backend is just a JavaScript object. Incorrect. Backend is a process. It has a memory. It exposes interfaces. Kind of like with RiverPad. It's another. You can think of it as another process of your app, right? And it has a memory, and it changes it based on the um, data returned from Supabase. And it also exposes interface. You can change value if you're allowed. If you change value, that's how you RiverPad help Flutter, change the widget or the UI state. The confusion comes from serverless. In Vercel, your backend runs JavaScript, but it is not your front end. It is a separate execution context because everything is eventually compiled to JavaScript. So though your Vercel is the runtime where kind of like the back end. The Vercel is really your our back end, but it is not our front end. We use Dart language or syntax that allows us to convert that to JavaScript that will now run on that back end. It is a separate execution context, even if written in JS, where your understanding slides slightly handy-wavy. Handy-wavy area number 1. Provider provides access control to state. More precise, provider defines who can read, who recomputes, and when disposal happens. So that's the life cycle definition that provider does. Let's say you have rep.watch. So that's like declaring that you would watch or you would read or that function. So if that function change, you would recompute. So that's how you manage the life cycle. So it's not just like provider provides access control to state. It's not access control like auth, it's lifecycle control. Hand wavy area number 2, business logic can be state. Correct but incomplete. More precise, business logic is constraints on state transitions. Because in order for your app to work properly in all cases, to avoid like security issues as well, to follow the UI, and then to avoid like changing unnecessary data in database, you need to have restriction or the state. So that's the business logic. That's why business logic is constraints on state transitions. You cannot just recompute or read anything. It has like life cycle control. So the logic was designed like that. Redux reducers, RiverPad provider, recomputation rules, DB, RLS, row level security, triggers, and then constraints. Wavy area number 3. This is subtle but important. You sometimes blur state, cache, source of truth. RiverPad is primarily a reactive cache, not the source of truth. Profound misunderstanding to fix now. The centralized state is just many globals. No, correct model, the centralized state is referential transparency plus dependency tracking. That's why RiverPad scales. If you miss this advanced topic, optimistic updates, invalidation, concurrency will break your mental model later. So it's just dependency tracking with values and lifecycle control, not many globals. So it's not like a lot of root. So it's interconnected like a graph data structure. Bridging Redux to provider, clean bridge. Think like this: Redux store, river pad provider container, Redux reducer, river pad provider function, Redux dispatch, river pad invalidate or set state, Redux selector, river pad ref.watch, Redux middleware, river pad provider observer. Redux time travel exists because of a single tree. River pad gains scalability because of graph isolation. Interview questions increasing difficulty. Level 1, why does Redux use a single global state tree? Second, why does RiverPads avoid it? Level 2, how does RiverPad invalidate dependent providers? Why is time travel harder in RiverPad? Level 3, why is RiverPad better suited for async plus caching? How does provider disposal prevent memory leaks? How does a database wall stream map to URI activity? Why is pointer chasing bad for CPU caches and state grabs? Level 5, how do SQL triggers, riverpad providers, and CPU pipelines all exploit the locality? Yes, that's the unifying concept. So basically, all of them just want the locality to execute instructions faster. Final grounding sentence, memorize this. Redux centralized state to simplify history. RiverPad decentralized state to simplify dependency and lifecycle management. Both are caches sitting on top of deeper source of truth.